All right, so I'm going to show you how to graph something quickly in Excel that might have parameters in it. There's a couple ways you can do this. I have a nice little video of how to make scroll bars, but we're not going to go any fancy pants with this. We're just going to do something simple. So let's go to my in-class assignment where I had just one parameter. Let's go to this one, and I'm just going to screenshot that so I don't have to go back and forth. So I'm going to use my snipping tool and just look at this solution here. Paste that and dump it into my Excel file so I have it here. And I'm also going to use my solution to this. So let's go back to the in-class assignment, and I had actually the solution here, right here, with alpha and beta. Your alpha and beta from your homework will have a PAL in there as well, not just an EI. So recreating what I did in class with alpha and beta, I'm not really interested if you can copy notes down. I'm interested to see, like, what would you do? How would alpha and beta be different if you left PAL free? So in your homework, I needed to see an alpha and a beta that had PAL in it. Mine has a EI in it because I kept PAL, I think, I can't remember what I put PAL as, but my PAL was fixed as something and I just pumped it in here. All right. So now the first thing I'm going to do here is I'm going to put EI because that is a parameter and it has to be filled in. So I'm going to put 2000 here as my starter. Then I'm going to put alpha, which I had reduced down because I had PAL in it. So I reduced it down. So I'm going to actually put in the value that I got for alpha. And for beta, I'm going to put in here the beta value I have. Let's see, 0 and times, and instead of EI, I'm going to put equals A2 because that's where my, or just A2 because that's where my EI is. And then I'm going to subtract from that minus 0.137. So that's how I get, now when I see this number change, like 2200, I'll get the beta changing because EI is in there. So I wish I'd done this with PAL, but I wanted to give something for you to do. So your alpha and beta, what you're going to have that's different is you're going to have PAL here too, so that you can switch around PAL, and these alphas and betas should change as a function of PAL. So I'm not going to have that because I don't have PAL in here. I wanted to do this quick and dirty easily. Now I'm going to make my graph. Time is going to be in days. So I'm going to start it with 0, 1, 2, 3, equals F5 plus 1. So I can just have that go down. So I'm just going to take that down to 365 days. Let's make it a year. So I'm going to just take this down to a year. That's good enough. And then over here, I'm going to put my formula. I'm going to put pounds. I'll show you how to do pounds because that's more interesting. And I'm going to put my initial weight here. You can do something cool. You can put in here another column and put initial weight. So you can see the effects of initial weight. If you've ever watched that show Biggest Loser, your initial weight actually matters a lot. So I'm going to put my initial weight in kilograms or in pounds. Let's just put my weight. It's 122 pounds. And so my initial weight here is going to be B2 divided by 2.2, so I convert it to kilograms. So that's my weight in kilograms, because everything in the model is kilograms. I'm going to type in the model where I have example. I'm going to show you this in Wolfram Alpha 2, or Wolfram, your Mathematica 2 in a second. I had to download it, and it's taking over my screen. But if you see down in the example, I have the formula for the solution. Here. So I have the formula for the solution. It's beta over alpha times 55.33 minus beta over alpha times. So I'm going to do this. So I'm going to go equals beta over alpha $2 because that's where beta is. I put the dollar because I don't want that to scroll when I run down the formula. Divided by $2 plus 55.33 minus $2 divided by $2 again, and then times exponential of minus alpha, which is in C$2, and I'm going to times that by the day time, which is in G2, G3. Yeah, make it match up. Okay, so I have that. Boom. It gives me the next day. And I just go double click down here in the corner and it makes all the weights go down. Now let's suppose I wanted that to be in terms of pounds, not, this is in kilograms right now. So this is actually going to have me go up, but let's change all this to pounds. Well, if I change it to pounds, I'm just going to multiply all my answers by 2.2. Is that? And then I'm going to make this 2.2 here. I'm just going to take all the answers I got and just multiply it times 2. And there it goes. You can see my weight. So now I can start looking at what happens when I change my EI. So how do I do that? I just make a graph. I just go to scatter plot. And I chose this one because it makes nice thin graphs. So under 2,200 calories, I would be gaining weight. If I wanted to change that, and I like to actually have labels on my graph. So please label your graph. It's not that hard. This would be time in days. And this would be, over here, weight in pounds. And so now I can just change this. Let's make this 1,600, a Jenny Craig diet. There you see my weight going down. I would be a waif at the end of a year. I would be close to 80 pounds. I can also do the equilibrium value. I think I did that in the Excel spreadsheet I did in class. Steady state, where it's going to converge to was beta over alpha. So D2 divided by C2. So that's not good. I'm going to steady state around 30 pounds. Let's put in 1,800, which is the higher calorie diet. You can see the steady state changes. Let's put 2,000. You see my steady state changes now to something reasonable, 52 kilograms. And you can see like it's like 117.5 pounds. I shouldn't be losing weight. That's what this is saying. Like, it's not good for me to lose weight. All right, so let's see if my Mathematica has gone up. If it hasn't, I'll have to kind of... All right, so let's see. So what we would do, I'm not going to go through this, but if you want to use Mathematica, all you have to do is feed it in. Let's see, it might actually work. There we go. This might work and I might be able to show you. Let's see. All right, so does that mean I can get on? Maybe. Yep, I can get on. I can send you guys this. It's not that. Let's go here. Run in weight change model. Cancel. It says new documents. I'm not quite sure why. Okay, there we go. So in this, what you would do is you would set, you know, just like you did in an Excel file, you set EI is equal to 2,000, shift enter. W0 is my initial weight, 122, shift enter. My beta was 1 divided by 7,700 times EI minus 0.137, shift enter, whoops, equals, there we go. And then my model was this guy over here, beta. Oh wait, we don't have alpha in here. We've got to have alpha. Alpha was 0.00234. And then my weight model was beta divided by alpha time plus 55.33 minus beta divided by alpha, and that's times exponential minus alpha times t. So it looks a little bit more like it makes sense in Mathematica than it did in this. And then if you want to, you could put a 2.2 out here and go back up here and go 2.2 times to convert it to pounds if you want to see this stuff in pounds. And then just plot. I forget how it goes. Is it like this? T goes from 0 to 365. There you go. There's my graph. And then you can go, of course, make it look nice by going in there and changing labels, so forth. I'm not going to go into that. You can actually make it into pounds. I can see in 365 days with an energy intake of 2,000, I'm going to lose weight to 118 some pounds. It looks like it's right. It's doing what it's supposed to. So I hope this helps you with graphing. I usually don't give any information for graphing because I just feel like these are all tools and I don't want to give something prescriptive. So that's this.